Hey everybody, this is Larry. This is week two, Q2 of the weekly contest 363. Happy students. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one is a very tricky to read problem. I feel like every problem this contest is actually kind of hard to read, maybe except for Q1. So let me know what you think in the comments. Let me know how you did. Let me know if you're a happy student. But yeah, I mean, I think the first thing that I would try to do is to kind of give structure to this, to these inputs, right? The students don't really matter, or, well, okay, maybe that phrasing is a little poor, but no, what is this number? The happy number, whatever this number is. Yeah, if nums, they don't even name the thing. With this number, like, it doesn't matter, right? So you could sort it is the first thing that I would do. You could also try doing it with a frequency table, but I think for what I'm about to do, sorting it is more straightforward. So this one, honestly, for me, took a little bit of time to read correctly, also, just to be frank. But basically, what you want to do for this problem is to divide the entire class of students into two groups, right? A group of students that are selected and groups of students that are not selected. And in the way that this problem presents itself, you want to group all the like if there, I mean, you know, there are a number of number of ways to do it, but a possible way will always include numbers that are separated in a sorted way, right? And you could kind of come up with a very obvious case where that's where if you don't do that, that's not going to be true, because then by definition one of these things will be violated, right? Meaning, for example, if you selected someone who's in 5 but not another person who's in 5, well, by definition that's just going to be, you know, wrong, because one of the, like, you know, the way that these conditions are set up, one of them will always going to be false, right? So that's basically the idea. And once you kind of realize that you're trying to split it up, then you just kind of have to ask yourself, you know, and the sorting is where this comes into play more, is because once now you can ask yourself, is the possible group have 0 students, 1 student, 2 students, 3 students, ... right? And in that world, now in the context, and I'm here because this is so hard to read, I'm not gonna lie, like I still like have trouble kind of just reading this particular problem, but basically now you're basically dividing the class into two groups, where the selected group is represented by the biggest number, because the number of selected students has to be bigger than the biggest number. And if it's bigger than the biggest number, it also means that it is bigger than all the other numbers, right? And in the same way, all the students that are not selected are represented by the smallest number, because the total number of students selected is going to have to be smaller than that number. And if it is, then it's smaller than every other number that is bigger than it, right? I'll give it an example, because I feel like the way I say it is a little bit awkward. But let's say after sorting, we have, you know, I don't know, I'm just like banging on the keyboard a little. And of course, there are dupes and stuff like this, don't forget. So something like this, right? And the idea here is that if we say, let's say we have a group split here, and this is like a bar, just exclamation mark, just slightly easier, right? It means that whatever this number is, the number of students, and let me copy and paste here, actually, hang on. Yeah, so that means that we have to select all these students, because or we don't have to select all these students, but one possible way to check is that you know, basically, if the total number of students selected is greater than this number, then that means that it's greater than all these numbers, right? And same thing, but for smaller in the other case. I just want to, I mean, I always said this, I just want to visualize it in that way. And once you do that, then the sorting also becomes more sensible, because now it doesn't, like I said, it doesn't really make sense to kind of mix in any other way, right? Because let's say we wanted to select the 10, but not this 10 anyway, and not the 8, right? Well, this doesn't make sense, because now this can never be be a possible group, because now you're trying to find more than 10 students, but also less than 8 students, right? So that's basically kind of the idea. And yeah, and now we'll go over my code really quickly. And once you have that visualization, I think the code is pretty easy to understand. After we sort it, we track the number of total counts of groups that we can do it. This is basically if we have 0 students. So if you can select 0 students if the smallest number is less, or if the smallest number is greater than 0, because then now this satisfied, right? Because no one is selected, and every and every num selected is less than, the smallest number. So yeah. Otherwise, then you have this divide, where this is just to make sure that the condition is true. You increment by 1. And this is for if you have everybody in the group. And that's basically it. This is going to be linear time. Oh, sorry. Well, this part is linear time, but this is obviously you have to do some sorting. So this is going to be n log n. You could maybe get away with it if you do some frequency table stuff. So in a way, you're kind of doing a bucket sort or something like this, or accounting sort kind of, and that would let you do it in O of n time. But I mean, it's easy to mess up there. So this is probably fine for me. I mean, and you could even just do a bucket sort, I guess, because you know that. Actually, I guess it doesn't have to be within. Oh no, it has to be less than n. So yeah, you could do a bucket sort or accounting sort. Sorry, and then just sort in linear time if you really care about linear time. But yeah, linear time, linear space, and that's what I have for this one. This is kind of tricky, so definitely, yeah. Let me know what you think. Let me know how you did, and you could watch me solve it live during the contest now. 13 and 1, all right. Probably should have taken an extra second. It's so easy to misread and just eat a 5-minute penalty. Okay. Say what? This one is kind of hard to read. Okay. So everyone is happy. Okay. Let's see. If the student is selected and the number of students is greater than it. This is hard to read. I mean, it's probably just sliding windows, right? One, 2, 3, and 6. They're just sorting then. Right. Let's see. If the student is selected, this is so hard to read. The student is selected and the number of okay, so you select I plus 1 students, and the numbers that are selected is going to be all the ones to the left. So num sub I, if this is greater than or equal to I plus 1, then I think. It's an everyone number, and okay. And num sub I plus 1 is now this is the other way. Strictly less than, so something like this even. This goes on there, but can you do 0? No, let's just do right? Yeah. And then now if num sub n minus 1 is less than n, then we add, this is so hard to read. 1 and 3, that's not right. Right. So 0. So if we select both of them, that's one way. If we select one of them, oh, select no students. How do I select no students in my way that I do it? If num sub 0 is greater than 0, I think. This is so easy to make a mistake on. I'm so like not confident about this, but let's give it YOLO. Okay. So easy to make a mistake on that one. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.